This question was from one of the GCSE papers fairly recently. So it's just a bit of programming. We've got 4 variables that they've given to us, which is in pseudocode. So just remember, obviously, we've got to recognize the idea of pseudocode, even if we don't have to write very much of it these days. But we've got 4 variables here, and these backwards arrows are just assignment statements. So country equals United States of America. It's very American based. State is California, etc. So we've got 4 strings basically. So data type string. So string is just a collection of characters, and it's in between the quote marks is where the strings are. So the first question was about concatenating the contents of the variables city and landmark. So some of my students, they could definitely do this. We've done this lots of times in programming, but remembering the word concatenating was the difficult problem that some of them had. So they weren't quite sure what concatenating meant. So concatenating is just sticking together 2 strings. So if we look at a bit of code for that, concatenating 2 variables just there, city plus landmark, and all I'm doing is printing those joined variables together. So if I run that program, we should see the first thing that we get is San Francisco, Alcatraz Island, no spaces in between. So if we go back and look at the question, San Francisco and Alcatraz Island, no spaces. It's just there. So that's the one that we needed. So that's concatenating. So it's one of the words we need to remember in programming, concatenating, sticking together strings. So they're just, if you're going to do a plus, one string plus another string, it's going to just stick those things together. So if there's a space here, it'll save that space. If it just puts 2 variables together, there'll be no space in between them. The next one was this one, which was about finding the length of something. So this is almost the same as Python. It's just the backwards arrow instead of equals. So x equals len state. It's the length of the state. So all it is the number of characters in it. So if we look at California, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 characters in it. So the answer is going to be 10 characters. And again, if we look at a bit of programming for that, then we've just used a variable here to say state length equals len state. And then we're just printing it. So when we run the program, we just get the length of the string for the state is 10, which it is. And that one was a nice easy one, hopefully, for most of us to think about. So len gives us the length. And, the only thing that people get a bit confused with is that this is a variable. It's called state. They've given us this variable here. So they're not asking us for the len of state, which would obviously be 1, 2, 3, 4, 5, which is probably why they've got this 5 in here to confuse us, or to throw us off the scent a bit. But the len of state is the variable, so it's the length of California. Okay, so the next bit on this one was here, where they're asking us to work with a substring. Now, you've got to read the question really carefully on this one, because it's slightly different the way that Python does this to the way that they've done it. But they've decided that they're going to use something called a subroutine called substring, which takes characters from a string. So in Python, you can do this anyway without a separate subroutine, which we'll have a look at in a moment. But substring 3, 5, and computing, that's giving it the string, would return put. So with computing, we've got 0, 1, 2, 3. So 3 would be P, and that's the first one it's giving us back. And it's returning 3, 4, and 5 as characters, so it's put. So that's giving us a clue as to how this works. So then we've got substring 4, 7 and landmark, and we need to look back at landmark's Alcatraz. So Alcatraz 0, 1, 2, 3, 4. The first character is a T. And then it's we need 5, 6 and 7 because it's including it. So 4, 5, 6 and 7 is RAZ. So it's TRAZ. So it's going to be D. Now, if we look at the programming for that, so finding part of a string. So I've said here, obviously note in the paper the range is different because Python deals with ranges in a slightly different way to that. So if we run this program, we've got our range of 4 to 8 here for landmark. If we run the program 4 to 8, it's going to come back with Traz, which is the correct answer. But in Python, our substring idea here, our range is a bit different. So we really have to read the question carefully on that one. So they've given us an example for that reason in here so that we can look at this example 3.5 and say, look, this is put, so we can apply that then to landmark. Yeah. So we've got to think about that one quite carefully. So then the last one on this is about a subroutine called position, which again we can do without a subroutine if we want to in Python, and we'll have a look at that in a moment. So they've given us another example, so we've really got to read it carefully. So position computing P returns 3. So 3, it's the first time that P is in this string. So we end up with computing position 3, 0, 1, 2, 3. So we can do this if we want to on the side of the paper to make sure we know we're doing it right. So 3 is P. That returns 3. So what we want is the position of landmark T. So landmark, again, it's Alcatraz. So ALCAT is 0, 1, 2, 3, 4. So the position of T is going to be 4. And it's always, there's nothing to stop you from writing these things down on the side of the paper to make sure you get this right. You need to try and really maximize the point scores on these questions. So again, finding the location of the first time that comes across a letter, we can do it just by using .find. So pos equals landmark.find T and print pos. And if we run that, in this case, this time it works in the same way in Python, so it gives us a 4 as an output. So just a few multiple choice questions from that paper, but things that we just need to be careful reading the questions, and we also need to know about some of those words in programming like concatenation.